Area of a parallelogram. Guess what? This once again is on your reference sheet. Area equals base times height. So we're given an example problem over here where your base is actually 12 and then your height is given as this dotted line of 6. Your height is not this red line here of 8. That is not your height. If I went ahead and took my lasso tool and then moved this height over, you can see that it is much longer than the actual height. So this side diagonal length is not, I repeat, is not your height. It is that blue line, or when I erase it, it is the dotted line. So that is a very important thing to take note of with parallelograms. So let's jump right into our first example. Find the area of this parallelogram. Here is a bunch of labeled side lengths, but we know, and if I go ahead and highlight this parallelogram right here, that's what we want to find. They just drew in dotted red lines the height, which made it a right triangle, but we don't want to overcomplicate things. Here is our height. That would be this line here, which we're told is 43.5. So if I actually went and brought this over, your height of the parallelogram from your base, so here's our base over here, to the top of it would be 43.5. So all I have to do is plug in area equals base times height. My base was 49.6 kilometers. My height is 43.5. Put that into your calculator, and your area equals 2,157.6 kilometers squared. So that is a superficial answer to get 2,157.6 kilometers squared. Moving right along to our second problem, find the height given the area of the parallelogram. So we kind of have to work backwards here. We're told that the area equals 748.8, and our formula, remember, is base times height. So 748.8 equals, well, I know that my base length here is 32. So equals 32 times, let's just call our height x. So to solve this thing for x, I would have to then divide by 32. And when I do 748.8 divided by 32, I end up with 23.4 meters equals x, or in other words, my height. All right, kicking right along down to a rhombus. So we do have a formula for area of a rhombus, but however, you can just make those 4 right triangles, find 4 separate areas, and add them together. It's nothing really to memorize, nothing new. It's just a way that we can split up this quadrilateral called a rhombus and go ahead and solve it. Now, it is given by 1/2 d1 times d2, and we call them d for diagonals. So if we go ahead and jump right into solving this problem, find the area and the perimeter, which for time's sake, let's just go ahead and find the area for now, and then we'll see if we can find the perimeter. Remember, I am in the depths of Antarctica. The year is 1940 something, and I need to go out and ice fish for some food soon. So we're given that PR. I'll go ahead and put this in red. is 32. And then green, because today is Sunday, that's why I chose green. That's what QS becomes. So with a rhombus, these diagonals bisect each other. So if the whole QS green line was 28, I know that when bisected, 28 divided by 2 is 14. I also know that my red line PR gets bisected, and those are both 16. So there's really two ways that I could go about solving this. When you are given both full diagonal lengths, you can plug it into the formula of area equals 1/2 diagonal 1 times diagonal 2. And so in our case, this was 1/2 times diagonal 1, which was 32, times diagonal 2, which was 28. And you end up with the area equals 448 inches squared. Now, since you are not given this formula, you may not memorize it. Where did that just go? Well, the area disappeared. Thank you, Notability Update. So I'm going to write the answer there. But luckily for you, I was going to solve this again, saying you kind of forget what exactly is the formula. Well, remember, it's just 4 right triangles here. As I said up here, you can split the rhombus into 4 right triangles, find 4 separate areas, and add them together. So here's our one triangle, and then you have another right triangle, and another. So area for a triangle, remember, 1/2 base times height. Well, we know if I change this to purple, here's my base of the triangle. Here's my height of the triangle. There's our 90-degree angle. And if I do 1/2 of that, I will find the area of just this purple triangle. So 1/2 times 14 times 16. And then, since we have 4 of those smaller triangles, I can go ahead and multiply whatever this answer is by 4. So 4 times 1/2 times 14 times 16. And what do you know? When I plug that in my calculator, the answer is 448 inches squared. And thankfully, those match up. So moving on down to area of a trapezoid, and then we have to find the area of a kite, and we'll call it a day on notes. So we do have a formula for the area of a trapezoid. However, you can just split the trapezoid into a rectangle and triangles, kind of like we did way back on the warm-up. So the official area is height, and then in parentheses, base 1 plus base 2 divided by 2. So let's go ahead and jump right into an example here. We're given the height. Again, it is dotted in red here. So my height is 15. My B1 and my B2, these are the parallel sides. I've just highlighted in green. So in parentheses, there we have that, divide by 2. I don't know why I put another equal sign there. Get rid of that because we are multiplying here. And plug that all into your calculator to get 274.5 centimeters squared. So that one was just plug it into the formula, go about our ways. Pretty easy. But what if we're given a second problem like this and we don't know this height value right here, and it makes me kind of want to panic a little bit. I'm on the test, summer's on the brain, I just want to get it over with, and I don't know the height. Well, what if I just draw that line there and create a right triangle here, and then create a rectangle here? And then I can go ahead and maybe solve this problem out a little bit. So, we're asked to find the area and to find the perimeter. So, let's break this down. This whole guy here is 13. This part up here is 10. So if I were to drag this length of 10 down, that is also 10. What is the remaining piece over here? Well, this must be 3, because 10 plus 3 will get me to my full length of 13. So I know some parts of this right triangle now. I can go ahead and use Pythagorean theorem to solve this right triangle, or some of you may recognize this as a Pythagorean triple. So 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. B squared equals 16. You undo the square by square rooting. So we now know that x equals 4. So this is a 3, 4, 5 Pythagorean triple. So now I know my height, I know my b1, I know my b2 value. I can plug this into the formula. My height was 4, base 1, 13, base 2, 10. Divide that by 2, and my area equals 115. If I wanted to find the perimeter, well, I know that my height here is 4, so this height will also be 4. Height cannot change. So I know that this is 4, and perimeter is just adding up all of your sides. So 4 plus 10 plus 5 plus a 13 gives me a perimeter of 32. And on to our final segment here, the area of a kite. Again, we're given a formula, or they created a formula for it, but you can split your kite into 4 right triangles and add them all up together. Surprise, surprise, this is also formula for a rhombus. So if you come across a kite or a rhombus, you're going to use the same type of formula. So here is our lovely kite here. We have our lines that I'm putting in this lovely teal color to create some right triangles. And we want to find the area below. So if I'm given, let me pick a fun color here. Let me pick this orange color here. We know that this length is 10, this length is 10, this length is 10. What we are missing is this length right here that I just made red. But we have a right triangle that we can go ahead and use our buddy Pythagoras' theorem. So when I use Pythagoras' theorem, I get 10 squared plus b squared, which is what we're looking for, equals 26 squared. So we end up, when I plug this in, we get 10 squared is 100 plus b squared equals 26 squared, which is 676. Move my 100 over. B squared equals 576. Undo your square by square rooting, and b equals 24. And now I can go ahead and use my 1/2 times d1 times d2. So 1/2, my diagonal 1, which I'm going to make this full blue line here. Remember, you have to add 24 and 10 together to give you 34, and then 10 and 10 together to give you 20. So our 10 and 10 would be this new purple line here. Plug that into your calculator, and your area equals 340 centimeters squared. All right, last problem for the day. A kite has an area of 226 inches squared. If one diagonal is 19 inches long, find the length of the other diagonal. So our formula, 1/2 d1 times d2. Well, our area is 226. 1/2 told us that the length of one diagonal is 19. We just have to find our second diagonal. So I can go ahead and simplify right here. 19 and 1/2 gives you 9.5. So 226 equals 9.5 d2. Go ahead and divide this by 9.5. And your second diagonal equals 23.79. And since we were told this problem is inches squared, that diagonal would come in inches. So I know that this lesson is very formula heavy, but do not lose sight of our prior knowledge of right triangles, special right triangles, Pythagorean theorem, radius and diameter of circles. All of these things come back into play and will connect one way or another. So this is our areas of polygons day 1. Tomorrow we'll do some more stuff with polygons and areas, and then we'll be off and running.